Hi, it's Mrs. Pope, and today we're going to talk about roots and zeros. Our goal is to determine the number and types of roots for a polynomial equation. We're going to find zeros and write equations for polynomials. So those are the two main things we're going to do today. Before we get started, I want you to consider this function here. Look at that, figure out what the degree is, the leading coefficient. This has a degree of 4, the leading coefficient is 1, and look at the graph of it. I just want to talk about the different vocab that we keep using: zeros, roots, factors, x-intercepts, and they're all related. So the zeros here, or the roots, are where they cross the x-axis. So just listing them, -3, -2, 1, and 2, that's where they cross the x-axis. If you wanted to write these as factors, your factors are x minus your root. So x minus -3 is x plus 3. X minus -2 is x plus 2. X minus 1 and x minus 2. So factors are x minus root. And then your x-intercept is just writing them as ordered pairs, as zeros. So -3, 0, -2, 0, 1, 0, and 2, 0. So they're all related to just where this graph crosses the x-axis. That is what tells you the solutions to this polynomial. Also see that that 4 is there, and look at how many we have. All right. Which brings us to the fundamental theorem of algebra. Every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. So it's saying any polynomial has at least one root. It could be imaginary because it's in the complex. It could be a real. It could be a complex number, imaginary and real. We don't use, that's kind of obvious, we don't use this as much. What we really use a lot is the corollary theorem to the fundamental theorem of algebra, which states that a polynomial of degree n has exactly n roots in the set of complex numbers, which is what I talked about looking at the 4. So for example, x cubed plus 2x squared plus 6 has 3 roots. 4x to the 4th, with all these, 4 roots. This polynomial, 5 roots. So the degree of the polynomial, or the highest exponent, tells you how many roots there are going to be. Some may be real, some may be imaginary, but they would all total up. And some may be double roots, which we'll talk about. But they all total to the same as the degree of the polynomial. Very important to keep in mind. All right, so let's solve and state the type of roots we have. Here we have something that says solve. We could try factoring. Let's try that. So remember factoring, we want to find two numbers that multiply to a times c. So multiply to -10, add to -3. What are those two numbers? Let's see, -5 times 2, that's -10, -5 plus 2, that's -3. Yep. So this factors into x minus 5, x plus 2 equals 0. So that means x minus 5 equals 0, or x plus 2 equals 0. If you solve these, add 5 to both sides. Of course, x is going to be equal to 5. Subtract 2, x is going to be equal to -2. So these are our two roots, 5, 0, and -2, 0. So we have two real roots. The reason there's real, there's no imaginary number there. There's no square root of -1. So these are two real roots. And I know I've found both of the roots because there are only two that exist. All right, let's look at another example. Example 2. Let's solve this one. So this is factoring as well. We need to recognize that this is factoring the difference of perfect squares. So 16 is a perfect square, x to the 4th is a perfect square, and 81 is also a perfect square. So I could rewrite this as, taking the square root of everything, 4x squared minus 9 times 4x squared plus 9. Remember, the difference of perfect squares states a squared minus b squared equals a plus b times a minus b. So that's the fact that I'm using. So if we were to equals 0, don't forget. So I need to set each one of the factors equal to 0. 4x squared minus 9 equals 0, or 4x squared plus 9 equals 0. So if we solve this, we would add 9 to both sides. 4x squared equals 9, divide by 4. X squared is equal to 9/4. take the square root. X is equal to, since it's unknown, plus or minus square root of 9, 3, square root of 4, 2. So plus or minus 3 halves. So x equals 3 halves, and x equals negative 3 halves. So there's 2 of our roots, but we know there has to be 4 roots because of this 4. So somewhere else there are 2 roots that are hiding. Let's solve over here. Subtract 9 from both sides. 4x squared is equal to negative 9. Divide by 4, divide by 4. X squared is equal to negative 9 fourths. Take the square root. X squared is equal to plus or minus. And notice we have a negative under here, so that's going to be an I. We're going to take out that square root of that negative number by turning it into I. And then we still have radical 9 over 4. So x squared is equal to plus or minus. We know that's 3 halves. So we have 3 halves. That doesn't look like a half. 3 halves I. So x equals 3 halves I, and x equals negative 3 halves I. So 1, 2, 3, 4. 2 of our solutions are imaginary, 2 of them are real. Alright, let's look here. It's our last example. A little different. We're going to write a polynomial of least degree, and given this, when they give us the zeros. So they're telling you, for this polynomial, we don't know anything except the fact that it crosses the x-axis at 5, negative 2, and negative 1. That's the only information that we're given, and we're to write the equation for this polynomial. Well, here are the steps. First, you want to write the zeros as factors. Remember, it's x minus the 0. Then we're going to multiply it all out and simplify. So if 5 is a 0, the factor is x minus 5. Negative 2, that will be x minus negative 2, but we don't write double negatives, so that's x plus 2. And x minus negative 1, which would be x plus 1. So now we're going to multiply these together. My suggestion is to multiply 2, simplify that, and then distribute that to the third one. So let's go ahead and FOIL this one. X squared plus 2x minus 5x minus 10. So x squared minus 3x minus 10. And then let's multiply it by the last one, x plus 1. So x squared times x cubed, x squared times 1, plus x squared. Same thing for each of these. So minus 3x squared, minus 3x, and then minus 10x, minus 10. Let's put together our like terms and simplify. Cube, we only have 1 cubed. Squared, I have x squared minus 3x squared, so I'm going to have minus 2x squared. Those are gone. Negative 3x minus 10x minus 13x minus 10. So this will be our final answer. This is the equation for the polynomial that goes through the following zeros. And notice they gave us 3 zeros. It has a degree of 3. Thanks for watching, and remember, you are responsible for your own learning.